My name is Dan Kenigsberg. I work for Red Hat, developing, I maintain VDSM, which is our virtual desktop and server management daemon. And I would like to introduce this piece of software and to tell you that it is finally free, free. And during my talk today, I will try to describe what it is, what it does, why you should know about it and use it, slightly how it is built, the API exposes, its storage architecture, which is a pretty big part of what it does, and something about an interesting policy that it maintains about virtual machines, and a few thoughts about our bright future. OK, so what is VDSM? It is a node management API that we use in our product and Red Hat Enterprise Virtualization Management. It exposes a high-level API for managing a hypervisor node. This API has to abstract low-level details of the underlying Linux environment. Currently, we have flavors of this daemon running over RHEL 5, RHEL 6, and RevH, which is a flavor of the previous two, which is something that's easier to deploy, and customers love it. Tomorrow, and when I say tomorrow, I actually mean tomorrow, we want to support, we are going to support Fedora, which is more commonplace than the previous ones. And I'm looking for support for other distributions, but we need the support of the community. This is one of the reasons we want to be free to develop it in the open. OK, what are the responsibilities of our daemon? It is first and foremost responsible for maintaining the life cycle of a virtual machine. It does it using the previous API that we heard about, using libvirt. And it has also a direct communication channel to a specific guest agent that we use. It runs within the guest and helps us with various tasks that we have to do. Another thing that we are responsible to is bootstrapping a host and registering it to the framework, the management framework. It is a lot of nasty bits and pieces that has to be taken care of. Monitoring the host and monitoring virtual machines, configuring network of each node, it is the responsibility of VDSM. Managing the storage, each host has to expose storage to the virtual machines that runs within it. And we are also responsible for maintaining several policies, configuring the host and setting up triggering, for example, KSM, the kernel same page oh, I forgot the acronym, but the thing that OK, that's a fake acronym. The true meaning is something completely different, but let's keep it into a private discussion later. And we also have a very interesting policy which can be summed up that a running VM should keep on running. But it is important when a virtual machine is deployed, is provisioned with a smaller disk than it actually thinks that it has. We would like to do more to control quality of service of virtual machines and to do smart ballooning to decide which virtual machine has less memory to use on a certain occasion. As you KVM developers know, QEMU and KVM is good. All you have to do is type QEMU KVM, and you have a virtual machine. However, you have to read the fine print like in every product. and the fine print is very fine and very long. This is only a small part of the command line that a usual commonplace virtual machine has. Well, in our product, this is how horrible it looks like. So you have to use something much better, which is libvirt, that knows how to build such a command line and enables you to manage more than a handful virtual machines. This is what you have to do. However, it's not, you should remember that managing a virtualization node has much more to do than just firing a virtual machine. We have to take care of, we have many more responsibilities. So what can we do if we have thousands of machines that are defined in our system, and we have cluster of hundreds of hosts that we have to manage, multiple storage exports? What can we do? One solution is Red Hat Enterprise Virtualization, or it's open source upstreamy name Overt. VDSM is its node agent, what runs in a single node, and it was tailored for its need. Its development is agile. It is strictly specific for KVM. We care much less of other things. And Red Hat Enterprise Virtualization is finally being open sourced. And our open sourcing of VDSM is another step in this direction. We want that VDSM would be useful for other use cases, not only in our specific product. So just a quick look on a block diagram of what is the product of RevM and where VDSM hides somewhere here. You can see that there's Overt has this big block of Red Hat Enterprise Management that controls the whole concert of virtual machines. It has to communicate with authentication agent outside. It speaks to multiple hosts, has to expose storage on many servers, and can be accessed by clients, as you can see in the right-hand side. Let's speak about architecture of VDSM. It is written in Python, which is, some people may be astounded by this, but it is a natural language of when you want to develop something for management, when you want to debug and develop quickly. It is a big beast. It is multi-threaded, runs multi-processes. It used to run QEMU directly and build the command line word by word, but recently in the upcoming version of VDSM, we are using libvirt in order to do that. We still use our own agent that runs within the guest. We use it for specific tasks that I will discuss later. I think that the most interesting part of VDSM is the way that it implements. You can think of this as that it implements a distributed image repository over the supported storage types. We can enable various export NFS, iSCSI, fiber channel, and local storage on the host, and make it available for multiple readers and writers all over the cluster of that we manage.
Officially tested with a cluster with at least 100 nodes.
Excuse me?
Officially tested with 100 of...
Okay, that's the number. But I think, yes, I think 200, there's no real limit. I mean, the limit is 200 and something currently. But, okay, it maintains this distributed image repository. It maintains that on these multiple hosts, only one host can be write metadata, can create virtual groups, but all hosts can run virtual machines that, of course, may write to data that is exposed by this image repository. It scales linearly. We don't have a lot of overhead and communication between the nodes. So this is something that's interesting. And we expose image-aware APIs, things that are useful for starting up virtual machines to create a specific disk based on a specific image, for example, of RHEL 6 or Windows 7 or whatever. Something that drives our development is robustness, because we are responsible on our node. Central management has hundreds of nodes to care for, and it does not know the specifics of the problems that are on a specific host. So we are responsible to be ever responsive, and even though there are many, many problems that we have to take care of, one of them is evaporated NFS exports. For example, if you just lose access to NFS, it can run havoc on Python that uses this global interpreter lock to access files. And if you access file while you have taken this global interpreter lock, you have to deal with this. If you have other problems, for example, multipath and certain paths are lost, we have to deal with this. Even if our own node crashes, we have to make sure that the whole repository is still alive and kicking. Even though it's impolite to mention this in this forum, QEMU and KVM still has bugs, and we have to report such. We cannot really assume that everything is happy, everything is good and dandy in a specific VM. If QEMU is suddenly unresponsive, we cannot allow to be unresponsive. We cannot become unresponsive ourselves, so we have to report it and allow management, for example, to kill this process or decide what to do with it. But if we ourselves suddenly crash, again, we have to restart ourselves to do our best to continue on running. And of course, if I mentioned earlier that we have a single writer of metadata in the cluster, if this writer is for some reason unable to access storage, it has to fence itself and ask for someone else to become this writer, single writer. So I will go on very quickly on the API that we expose. I'm not going, I'm fearing the fingers of Chris that might be waved at me, so I'll just skim through it. We expose to our central management stuff like what are the capabilities of the specific node, what it can run, what are the CPU flags, which virtual machines with which CPU flags can be run on this host. We expose the statistics, for example, the network bandwidth that is currently consumed, the CPU, the memory usage. And we also enable central management to fence another host. This is a pretty funny trivia because our RevM used to run on a specific operating system that I won't mention its name, and it did not have a proper Python support that could not really use the Red Hat fencing agent scripts. And so we had to be the proxy for this. The most important thing about what we do is virtual machine lifecycle management. My colleagues from EMEA may know why this animation bit is here, but okay, so to start to run virtual machines, we have the usual, the most important thing is to spring up a new virtual machine. That's the create verb. This verb receives a chunk of definition that is translated into the libvirt XML API for the libvirt XML definition for domain, virtual domain. And then later translated to a QEMU command line. It is important to mention that since our node is really low in the change of management, all definition of virtual machines is stored in central database up in the stack. In libvirt lingo, all domains are transient. Nothing is stored on a specific host that may evaporate and die. Everything is just written once up the stack. As a machine can be created, well, a better name is sprung up to life. It can be destroyed. It can be paused, continued. All these verbs that you may want to do to a running virtual machine. Something that I would like to expand a little further is this nice diagram in the right that enables the user of VDSM to extend it because we as a team develop our product in a different time scale than what libvirt and QEMU and KVM does. And sometimes there are features that are available in QEMU and KVM, but are not part of the overall product of Ovirt or RevM. So we allow customers and developers to hook into VDSM, and for example, just before a new virtual machine is being run, we execute a hook script that may manipulate this the domain XML of libvirt, do whatever it wants to it. It can do very horrible harms to our system if it wants to, but it allows customers and developers to play with stuff that may be useful. And already I'm very happy to see that there are many usages of this feature that allows us to support things that we simply did not have to streamline and support ourselves. So it's a nice stuff. As I mentioned earlier, there is a quite important part of what we do is depends on the availability of an agent within the guest. One of the things is to do a polite shutdown. Sometimes, or usually, when the manager or the administrator of the overall cluster wants to shut down a virtual machine, he does not want to surprise the user of this particular machine or the application that runs there. So it notifies the guest, and the user can decide whether it's a good thing to do now, to shut down, to clean his editors, and to shut down all the applications. But something more cool that this allows also what we call a single sign-on. It allows a user to log into our central management to receive the credential, and the VDSM passes these credentials into the guest, so the user may only type his password once and be used for all his virtual machines, and so it makes the user experience more fun. You don't have to retype your password. Okay, our virtual machines are obviously monitored. We can report stuff that we gain from the agent, for example, the memory usage, interesting applications that are being run on the guest. These are stuff that may be interesting for the administrator of the overall system. For example, the management user interface allows to select all the virtual machines that are running a specific database application, for example, and do some management operation on them. So this is how this information is propagated from the guest to central management. We do, this is, I have here a typo in the title, because network configuration API is totally unrelated to the agent. This is just a typo of mine. This is something that I'm pretty proud of, that we finally we implemented this several years ago, that allows central management to configure host networking on each node. This allows us to define the finger, to define virtual network on each node, and it allows virtual machines to seamlessly be migrated from one host to another, and still not to lose connectivity. So now that libvirt has this ability as well, we will be happy to use, to move and use the API that libvirt exposes. Let's not speak about stuff that is less important. Just a quick discussion about our storage architecture. As I said earlier, we have a single metadata writer that obtains a lease in order to become this role of metadata writer. It is the only one that is allowed to create virtual groups, LVM, but everybody else may use this, what we call storage domains that are created by the metadata writer. There is an interesting, we have a storage-centric mailbox that allows communication from your random host and this metadata writer. It allows us, what I wanted to discuss now, this maintaining of a virtual machine that is deployed with thin provisioning. In this setup, we create a logical volume, which is, for example, 1 gigabyte of size, and within it, there's a QCOW image. And inside the block device, there's a QCOW image that its logical size is much, much larger than 1 gigabyte, for example, 40 gigabytes. Because it is based on another template that is 40 gigabyte long. It may grow as the virtual machine lives. So when QEMU is running and writing, the guest within it writes to QCOW. QCOW has all this overhead and generates another cluster. It may well be unable to perform this write because the LV is too small. In this moment, this write would fail with inno space. This event is reported to VDSM, which then writes in our mailbox a request to the SPM, the single writer. It requests the extend message. The extend message is taken from the mailbox. The LV is then being extended by another chunk, by another extent, and a completion message is returned back to the first host, which continues the operation of QMO. This is very quick. It can be few seconds. At worst, it is a few seconds. We would like to be notified a bit earlier that we are nearing the end of LV, because we don't want to destroy the nice experience of the guest that it is being stopped. So this helps us to maintain a virtual machine that it would continue running and does not, we do not have to bother the central management about the little details, how it's done. It just runs. Okay, what we would like to do in the future? We would like to improve our API, which it is not written here, but it is not the best. We want to use a new API, make it stable. Probably it would be RESTful, because it would be similar to what RevM API is. We'd like to clean it up. We would like to split VDSM to reusable autonomous parts, and maybe spin such autonomous part as a generic image repository, because what we do for virtual machine may be useful for other use cases when you have many independent writers that may be happy to use an LV or a file on an NFS, but not create that LV. For example, one of the things that we already spun off in a way is Sunlock that Daniel Beranger mentioned earlier. We would like to move our framework to use that spun off part. Instead of maintaining the leases ourselves, delegate this task to a separate tool. We would like to support all the stuff that is currently supported by libvirt and Red Hat Linux, for example, VEPA, VNLink. We would like to have specific storage network. I'm not sure. I don't have time to explain what's that, but we would like to support something that's pretty complex, which is a storage migration. Our competition has it and likes to wave it in our face. I'm not sure if it is very useful for customers, but customers ask about it. So we would like to allow to migrate the storage of a virtual machine to another storage while the virtual machine is running. We would like to support other use cases, not only being part of RevM. For example, now that we are open and free and happy, we would like to make it easier for developers or just people who want to try it out to run it simply on the desktop. And we may consider trying a Linux container, which may be useful for our clients, our customers. Okay, now that we are open, we have a mailing list and a Git repository, which is under Fedora. We have availability, visibility in IRC. We would love to hear from you if you have questions. And if you want to see it working, you are more than welcome to ask to come see Andy Cathro here in the second row. He has, yes, that's you. And he promised me he would have a demo, a nice demo of RevM and VDSM, all playing with no bugs and all ready for production.
Can't see the bugs.
Okay. Okay, thank you very much.